Welcome back to Fullerton College Pre-Press. This is Professor Ben Kiewit picking up where I left off on color management, one of my favorite topics, and one of those advanced topics that takes you from being an okay pre-press operator to an unbelievably good one. This is the elite. This is the prestige class of pre-press, understanding color management. In fact, if you go far enough down this rabbit hole, you could be earning a PhD in color science. Anyways, I'm excited about all of this. Color is such an interesting topic. So we were talking about the ICC and how they use lab color, because lab color is an objective, non-reproduction system. Lab color is not trying to create color. Lab color is only trying to scientifically define it. And because of that, other color systems can use it as a combined neutral space where they can all meet and try to agree on what colors actually are. Let's move on. You do this by making an ICC profile. Remember the International Color Consortium, the ICC. These profiles use the lab color space to define what any given device is doing. They call it fingerprinting. You print out we'll go into the details later, but basically you print out or you show on the screen a series of colors with known values. And you compare the known value, the agreed upon known value, the objective neutral truth of what color we want that to be. What if we all agreed that red is going to be what's our standard? And how close does this device, whichever device you're using, get to being that standard? How close is the red in my computer to the properly defined red in lab color space that we've all agreed upon? And a record of how close and how far it is from those different colors for any one of the target swatches is the fingerprint or the profile of that device. So now it is known that this device prints red a little bit too dimly, or this computer monitor doesn't show blue as bright as it's supposed to. And we all know now that you need to accommodate for those differences. Every device should have one profile. It doesn't have a profile of how it relates to every other individual device. Instead, it just has one that says what it is. It's like instead of trying to remember who you are in the sense of an entire family tree, as long as everybody just knows their own name, we're okay. So these are just name tags. This is what I am. This is what I'm about. These are the colors that I produce. With ICC profiles, here's our same chart simplified. They all go to the neutral lab color space and attempt to create the same target colors. That way they're agreed upon what the output should be. Of course, you still have to keep your machines calibrated and you still have to keep your machines maintained. If your machines aren't maintained or calibrated, go ahead and stop listening, stop talking to me, get out of my class. If you're not calibrating your machine, none of this is worth listening to. It's all worthless. This is pointless if you don't have your machines already running as well as they can run. You should never try to color manage a badly maintained machine. That is foolishness. So the profile connection space is the standard color space. Typically, it's lab color. That is the PCS, the profile connection space. That is the color space that they're all using as their common language. We'll use a better example. The bad example doesn't work because that language failed. If anybody knows the history of the language, Esperanto, it's out there. It's still used sort of, but it didn't really go anywhere. It involves the League of Nations, which didn't really go anywhere. Anyways, let's get out of that history. Let's go a bit farther back to the Middle Ages in Europe. There may be other examples from other parts of the world, but I'm afraid I'm not familiar with them myself yet. Not to say I wouldn't like to. History is a very interesting subject, and I'm always glad to learn about it. Anyways, at least in Europe, for the longest time, there were so many regional dialects of languages, even within single kingdoms in the Middle Ages and the Renaissance, where you may be speaking English, but it's very different English than the next town over. You may be speaking French, but it's different from the next town over. And everyone was connected by the church. The Catholic Church was a political entity that kind of ruled the Western world at the time. And what language did they use? Why, they used Latin as a connection space. It was very difficult for people to know what all these regional versions, what does your version of Danish mean? How do I know if my German is the same as your German? Well, that was a problem for diplomacy from all these small kingdoms and ever shifting alliances and trade deals. So what they did was whenever they needed to have a diplomat talk to someone else from somewhere else, they used the neutral language the church was using, which was Latin. The Roman Empire had gone away hundreds of years before, and its language had mostly died, except in written treaties, they would still write in Latin. You actually see this as a holdover in the modern Western world, where a lot of legal documents are still done with at least some Latin heritage thrown to them. It's one of the reasons that when you're talking legal stuff and getting the lawyer speak, so many legal documents have little bits of Latin here and there. When you hear things like ad hominem or quid quo pro and other phrases that get thrown around commonly still that are Latin phrases, they're still around because the language of diplomacy and legislature for the longest time was still Latin. And they did this because it was an agreed upon neutral language that wasn't favoring one country over another. They could all agree that this language had an absolute meaning. What you say in Latin is true. Oh, I ruined that. Let me try that again. What you say in Latin is veritas. Anyways, so this is Latin for printing and for other color management as well. I'm a printer, so I'm biased. See, that's why we need the neutral, because everyone's biased. All these devices are biased. The lab color space lets them all agree upon an objective outside truth. And that is a very important idea because that gets you into, you don't need to make profiles, plural, for devices. Every device just needs its own profile to understand how does it relate to the agreed upon profile connection space. Sorry, I went kind of long on that, but it's an important concept. So lab color, ooh yeah, called C-Lab, is based on the human perception. It was actually done originally in, I believe, the 1970s. You can Wikipedia me and prove me wrong if I'm wrong. I'm flying in the seat of my pants here. But it was done originally. This is actually the L star, A star, B star. Why are there stars? This is actually the second C-Lab color space. There was an older C-Lab, which was just LAB. It wasn't L star, A star, B star. And that was done off an original survey done in France in the 60s or 70s. I really do want to say 70s, where they surveyed a couple thousand people and they had them come define the differences they saw in colors through some viewing of cards and relating what they saw. And they were able to map what the average human, the average of 1,000 Frenchmen in 1970, were able to see. And they were able to kind of decide what the limits of human perception were. Again, it was very limited. And the math wasn't all the way there for how they wanted to map it. They made changes to it more recently. I don't have the year off the top of my head. I am sorry. But the L star, A star, B star, if you know some things from different mathematical things and different bits of science, this is telling you this is kind of like L prime, A prime, and B prime. These are L, yes, is the same concept as the original L and C-Lab, but this is actually version 2. It's a different version. It's L star, guys. But anyways. So it's actually the second one. They did their best to figure out what human beings are capable of seeing, what level of difference and change can we see and actually perceive between two colors, and what is the most of a color we can see before it just stops looking like anything to us. How bright can we notice? How dark can we notice? We're really charting how sensitive are our eyeballs. And so lab color then charts in a 3-dimensional graph all the colors that humans are capable of seeing. Of course, it's maybe not the average human is capable of seeing, because of course, with any sort of survey, any sort of poll, you're taking a small sample and extrapolating the results to mean everybody, and that doesn't always work. But lab color is still the best we've got, so I'm going to go with it. And it's device independent, because lab color is about how you and I see things and not how our devices recreate things. That makes it independent of the devices. It doesn't matter what device you're using. Lab color is still the same. And it's important for color management because it allows you can even use the lab color mode in some documents. Photoshop supports it. And while it'll still show you RGB on your screen, because how can it not? That's what your screen does. It's remembering LAB values. And if you work with those values, when color management is very important, whenever you reach a device, it will translate those LAB values from lab color to whatever bad word there because that's incorrect. It will use its profile to translate lab to how it would show you that same color. Again, luminance, A and B. Luminance is light to dark. A is red to green, and B is yellow to blue. This is charted based off of human perception. In our eyes, if you've ever seen those charts, maybe I'll put one up for you to look at, or one of the other videos I think in the color management series I gave you has a thing where you stare at a weird color negative of the US flag where it has black, cyan, and red where they shouldn't be. And then you turn it off and look at white all of a sudden and you see the correct colors. Human vision works two ways at the same time. On one hand, when you see blue, the blue cones in your eyes are being activated by the light that's hitting them. On the other hand, you see blue when something is light, but you are not seeing red or green, which is the same way of saying when only the blue cone is activated, not the red or the green ones. Yellow is red and green light mixed. So blue is it's not just the presence of blue. Blue is also the absence of yellow. And red and green, although it's not exactly red and green, it's more like a magenta and cyan, you might say. Those two opposites are also, the more green you see, the less red you see. The more red you see, the less green you see. So those are the two XY axes of this XYZ three-dimensional graph. Again, refer to the fruit chart. I'll make it downloadable for you guys this time. Because remember, big B is banana, little B is blueberry. Bananas are yellow, so positive B is yellow, negative B is blue because blueberries are small. And for red, apples are red. Red apples are good. Green apples are blech. So negative is green. A positive is red. Simple, right? Okay, so the process of managing color on devices. First, you have to calibrate. Your device must be outputting consistently. This is like another one of my hobbies, archery. In archery, it's more important to be consistent than accurate. It's better to drop all your arrows in the same place than to drop some of them on the bullseye and others all over the place. Same with your press. It's better that it does the same thing every time. Even if it's slightly wrong, doing the same thing every time is something we can account for. Characterization. Once you have it doing the same thing, then you can say, what is it doing? And you can make a profile for it. And lastly, you can convert. Conversion is when you take your knowledge of your profile of where you're wrong and make, it's not a lot of times a digital script that'll make changes for you. If you know your red is going to come out way too purple, then conversion is saying make that more red or make it less purple, pull out some of the cyan from what it's doing. Anyways, there's another way of looking at this one, and I can speak from experience of having spent many years driving a really bad car in my impoverished youth. I had a car with really, really awful alignment. You may not all drive, but alignment is which way your wheels are pointing. And it's possible to drive with your steering wheel straight and you go straight down the road in a well-maintained vehicle. If your car is in bad shape, as my old Toyota was, you had to turn the wheel to the left to make the wheels go straight. You can also think about this like if any of you have played video games with the controllers, if you ever have a controller analog stick pressed to the side before you plug it into the console, then you spend the whole game with your character spinning in circles, you have to push the stick the whole way over just to get it neutral. That is also conversion. Anyways, so the calibration kind of visual here is you're driving a car with bad alignment. So if you know your car is always going to veer to the left, well, then you keep your car steering wheel turned to the right to drive straight. And you just drive down the freeway with your arms turned to the right the whole time. By the way, that does get you tired too. You can also know this from shopping. If you go to the grocery store and the shopping cart likes to slam into the left wall, you have to push harder to keep it straight in the middle. So calibration is making sure that it's always going the same way at the same thing. If your wheels are flopping back and forth on your cart or on your car, ooh, that's really bad. There's nothing you can do for correcting. You're just going to be wobbly all over the place. Can't fix that. But if they're consistently to one side, you can consistently push back to keep yourself straight. All right, we're going to stop here and we'll come back in another recording.